everyone. Hope everybody is doing okay. Welcome to our webinar. My name is Rochelle Frybren and I am the moderator for today's webinar. Tech Talk, Secure Wi-Fi Setup in Standalone and Nebula. I would like to bring onto the podium Marcus Holmes, Zyxel Sales Engineer. Marcus has been a part of the Zyxel team for over 10 years. But before we continue, I'd like to point out some housekeeping. During the webinar, you'll see three options at the bottom: raising your hand, a chat field, and a Q&A. If you have any questions, feel free to use the Q&A and not the chat field. Marcus and I will be moderating these questions and answering them at the end of the webinar. Also, this webinar will be recorded for your future needs. I will now turn this mic to Marcus. Marcus, take it away.
Thank you, Rochelle. I hope everyone's having a good and wonderful Thursday morning or afternoon, depending on where you are. Today, we want to talk about the secure Wi-Fi service that we have on our firewalls and in Nebula. And so I want to talk about what the use is and what the use case is, and then how to configure it in both the standalone, which is the on-premise mode with our firewalls, and then how to get it installed into Nebula. So take a look at our agenda for today. So our agenda, we're going to talk first about secure for Wi-Fi and what it is. And then we'll look at the standalone setup and then the cloud setup. So let's take a look at secure Wi-Fi and what it is. So the motivation behind secure Wi-Fi. Well, there's been a larger need for customers to deploy units for their work from home employees because there's a huge movement of people starting to work from home more often. And so what that means is we need a way to secure a connection back from where their location is to the main headquarters office. Now, there is an option for doing your SSL VPNs or your IPsec VPNs. However, that does require you to install software on that particular person's machine, and that can cause some problems, specifically if they are behind a double NAT, or if they are if they don't want to have anything installed on their laptop, or if you're having a laptop that's going to be given to them, there's the extra overhead, added cost of, getting the software and then getting the software provisioned so that they can connect into your network. So we do have something, or we had something very similar with our access points, where you can give a customer an access point and they can take it home, and you can use something called tunneling mode. The problem with tunneling mode is the traffic was not encrypted over the GRE tunnel. So with our NXCs, which is our older Wi-Fi controller, you could set up a GRE tunnel. So the customer can take an access point home, and then they can set up a GRE tunnel, and that GRE tunnel will connect back to the headquarters, and then it'll be as if you were on the network like a VPN. But again, the problem here is that the traffic is not encrypted; it's insecure, and we want to actually make sure that that connection is secure. So you'll see here inside the original packet, when it's going in the GRE tunnel, you'll see that the source and destination are inside the packet along with the payload, but it's not encrypted. And then you'll see in the GRE tunnel here in the original packet, then we have the GRE tunnels portion here. It has the source and the destination being the public IP addresses on both sides. So when you have your GRE tunnel, it does put the information inside the packet, but the problem is that the traffic's not encrypted. Now, if we do a secure Wi-Fi tunnel for the SSID, we can actually provide data encryption within the payload. So with this particular type of remote site VPN with an access point, what you end up doing is for your work from home worker, you end up giving them an access point that's already pre-provisioned to connect back to the gateway. And then it builds a GRE tunnel over IPsec, and that traffic is then encrypted. And so therefore that traffic is it's safe, and therefore it is protected through the VPN over the IPsec connection through the GRE tunnel. So here again, we can see the source and destination for the local address and the private IP address. We have the external source and destination, and we have the IPsec source and destination inside the whole packet. Now, with the secure Wi-Fi, what this also means is that you program the access point to have a specific SSID, so that when you give it to the employee and they take it home, all they do is plug in the access point and connect to the specific SSID. The GRE tunnel with the IPsec over the GRE is actually going to be tied to a specific SSID that's broadcast. So when that particular user who's working from home connects to that particular SSID, we'll call it maybe the work SSID, they're able to then connect directly back to the headquarters enterprise network, and they're able to access local shares and other devices as if they were local to the network. So here we can see with the secure Wi-Fi, we have the source and destination in the packet itself, and then everything else inside the packet is going to be encrypted because it's going to be going through the IPsec. So it's the GRE over IPsec, and so everything is going to be encrypted. Now, when it comes to the secure Wi-Fi, there's a secure Wi-Fi license. In order to activate this either in Nebula or on standalone, you have to get the license that comes with it. It is a time-based license. It's not perpetual, meaning that you can either get it in 1 month, 1 year, or 2-year intervals. You get a 30-day trial when you get the ATP Gold Security Pack. So if you already have the ATP and you get the Gold Security Pack with it, you get a 30-day trial with the secure Wi-Fi license. When you move it from on-premise mode to cloud mode or standalone mode to cloud mode, that license will follow that device. So let's just say that today on July 7th, you end up getting that license and you apply it to standalone on your ATP or your USB Flex. You apply that license and it's good. And then maybe 30 days later, you decide that you want to migrate that particular firewall into the cloud. That license will then carry with it, so that if you have a 1-year license for your secure Wi-Fi, you've already used up 30 days, you still have 11 months left over when you move it to the cloud. Now, it is required for you to activate the remote AP function when it expires. So that basically means that whenever the license runs out, you will have a grace period of about 15 days. But the problem is that after that grace period has gone and come past and you haven't renewed your license, then all of your VPN connections to the remote AP will be disabled. Your tunneling mode and the SSID will be disabled as well. And then also you do have the option to do an auto recovery, so that after you get a new license, all of those functions will be reinstated once you apply the new license. And then additionally, again, you can maximize the management AP amount when you're using the secure Wi-Fi license. So the models that it supports, any AP controller with ZLD 5.0, that basically means any USG firewall, being the Flex and the ATP, those are the ones that are supported. The older legacy USG 110, 210, and 310, 1100, and 1900 are not supported with secure Wi-Fi. So because the Flex series and the ATP series do have an AP controller, as long as you're on firmware 5.0 and above, it is supported for secure Wi-Fi. And then, of course, our access points, our WAX access points, and select WAC access points with firmware 6.20 and above are supported with secure Wi-Fi. Now, when it comes to the deployment process, usually you have an enterprise or an IT engineer, basically for standalone mode, they are already going to be controlling access points. So when you're in standalone mode with our USG Flex or ATP, there is an AP controller built in, and you would use that AP controller to control your access points. Now, just be aware that by default, our access points can be controlled up to 8 as a minimum. That's the maximum amount you can control in the very beginning. But when you get the secure Wi-Fi license, that actually increases the amount of APs that you can control. So if you're already in standalone mode, you have 8. Let's say that you have 8 access points already, and you're controlling them. What you'd have to do is you'd have to go into each access point and configure them as a remote access point. That's going to be their role, because you first have to take the access points and then put them in your network, and then change its role to be a remote access point. And then you assign an SSID that's specific to that particular access point. Like I said, a work SSID that's going to be used for the GRE IPsec tunnel. And then you end up putting the WAN IP address of your USG as the controller IP address in the access point, which I'll go over here in just a moment when we go through the configuration. So once this is all done for the deployment, and it's been set up and that access point has the necessary information, the IT integrator, all they have to do is provide that worker with the access point and just tell them, here, just plug it in, it's already been configured. And then once they see the particular SSID for them to connect up to, they just connect to that SSID, and then they'll be able to be on the network as if they were local to the device. So let's talk about the standalone setup for the remote Wi-Fi. So setting it up in the actual firewall itself is pretty straightforward. you would just first check to see if it is capable of being controlled. So because specific access points do have this functionality and certain ones don't, what you can do is go into the monitor in the wireless section and then go to AP information, AP list, and then show advanced settings. Under the advanced settings, you can see all the access points that are being managed by the firewall at the time. And it'll tell you, there's a column on the far right that'll tell you if it is capable. So if it has AP role capability, it says remote AP, that means that that access point is a valid access point that can be used with remote secure Wi-Fi. If you see a device that doesn't have that capability listed, that means that it does not support the feature. So once you've gone through and checked your access points that you're managing to see if they can support this feature, the next thing you want to do is actually set up the AP role. So you would go into the actual access point itself. So you would go on configuration, you click on wireless AP management, and then management AP list. You click the specific access point that you want to configure to be a remote access point, and then click the option to set it to remote AP. The second thing you want to do is set up your secure tunnel SSIDs. So this is where you specify what the SSID name that's going to be broadcast that allows the customer or allows the user to connect to the tunnel that tunnels back to the firewall. So you specify what interface that they are going to be a part of, or you can do VLANs if you want to do as well. So you set up your SSID profile with the name, you choose your band mode, and then you choose what interface that it's going to be bound to for the tunnel itself. Then at the very bottom, you have local bridge SSID. So local bridge SSID is going to be for the actual SSID for the local network for that particular access point. So what we can do in this situation here is we can have two SSIDs that are broadcast. You can have the secure tunnel SSID, which is going to be the remote worker SSID to connect back to the firewall as if it were part of the network. And then you have the local bridge SSID, which is going to be for that employee's local internet access. So when they're connecting to work on that access point, they would connect to the secure tunnel SSID, giving them access to all the resources that's required for that particular worker to work. So they'll have share access or whatever you have set up for that particular SSID. The local bridge is going to be for them to go out their local internet. So that means that if they're connecting to the local bridge SSID, if they have one that just says local SSID, like in this example here, that means that all of their traffic that they push through the access point will go through their local network only, will not go to the tunnel as long as they're connected to that local bridge. So we have two SSIDs that are broadcast, one for your local bridge, for your local internet access, and then one SSID specifically for tunneling back to the work firewall. Once you've already assigned your SSIDs to that particular access point, then you need to enable the option to force override ACIP config on the AP, and then put in the WAN IP address of the firewall. So in here, we put 140.112.60.11 as an example. Let's just say that that's the main IP address on the firewall. Now take note, it does require that you have a public IP address. So if you're behind the NAT, you may need to do some port forwarding on your main router that's ahead of it or modem to forward the specific ports directly to the firewall so that you can gain access to it through a double NAT. Once this is done, you verify the result on the security gateway settings. So you can see the access point name here, the assigned IP address, and then the remote server IP address of what you're connecting to. Now, after all this is done, we need to do one more step, and that is that we need to apply a network range for that client that connects up to the secure tunnel. So to do that, all we need to do is go to enable the two settings to do this. So we're going to go to configuration, VPN monitor, remote AP VPN, and then remote AP VPN. This is where you can set an actual address pool so that when people connect in from the outside from those remote access points, they're going to be handed off an IP address from this address pool. And then because there's an address pool here, we can then go back to our firewall rules and create specific rules for the firewall itself. So let's just say that we needed to set up a rule so that someone on 192.168.60.5 only has access to specific shares on the LAN zone. So you can come in here to your firewall policy, you can actually set that up. And that's why that's why that option is there for the address pool, because that address pool will then apply to your firewall rule. Additionally, you will have to create a CAP/WAP to device firewall rule that will allow the services for the CAP/WAP, which is used for the communication protocol for the access point to reach the controller. So again, we have a service called CAP/WAP control that's already in the firewall as a service object. So that's what you'd have to do. You'd create a from WAN to Zywall rule, allowing the CAP/WAP control. Now, again, this is also going to be useful for if you need to do a port forwarding when you're behind a double NAT. You would do the service as your CAP/WAP control that you're going to forward to the private IP address on the LAN port. And again, that's only if you have a double NAT. Now, one thing you have to be aware of is that when you enable this option, when you enable the remote access point mode on the access point, it's going to enable broadcast storm control and multicast storm control. And that's only to help limit the amount of the multicast and broadcast that comes from the wireless, because, as the wireless is traversing the IPsec tunnel, the GRE tunnel, it's going to send, multicast and broadcast packets. So we want to limit the amount of doing that. And doing so will prevent a lot of frames from landing on your LAN subnet and then broadcasting out through your network. So this is automatically enabled by default. Now, when it comes to the standalone setup, you'll notice that the max amount of remote access points that you can have is going to be limited by two factors. First of all, each device has a hard number of max concurrent IPsec tunnels. And the second thing is that it's going to be 25% of the maximum amount of managed APs. So for instance, if you have a device that can only manage up to 100 access points locally with a local managed, that means that you're going to be able to only use 25 remote access points. So when you give out your access points, you have to adhere to that number. It's going to be 25% of the maximum number of managed APs that you can have. And this is particularly done so that it keeps all the devices from being overloaded, and it keeps the firewall from being overloaded as well. Now, one more thing to add is that if you are on an older firmware and you upgrade to 5.0, you'll notice that the secure Wi-Fi option will be added into the service status. So you'll see that it will be added here, and then when you activate it, it'll tell you how many secure Wi-Fi access points that you can deploy. So that'll be in the service status. It'll tell you exactly how many devices you can deploy in total. Now, again, when the license expires, you have a 15-day grace period to let the user renew the devices, renew the license on it. So that means that after your license expires, you got 15 days to purchase a new or renew a license. Your tunnels will still function, but after that 15-day period, those tunnels will be disabled. Once you get a new license, those tunnels will be reactivated. Now, for the cloud setup, it's pretty straightforward. It's slightly less steps. It's basically all in one screen here. So in order to do this secure Wi-Fi Nebula, first of all, your USG Flex or ATP must be in the same organization and site as the APs that you have and want to deploy for your remote AP. And they must have the secure Wi-Fi license. So once that's been done, all you would need to do is go to access point, monitor, access point, and then choose the access point that you want to modify. So here you'll see that we have one called remote 01. We would click on the little edit button, which brings up this little screen here. And again, all we need to do, similar to the standalone mode, is first enable the remote access point and then enter in your SSID. So we want to do an SSID called company. We're going to tunnel to the LAN 1 interface. And then, of course, we have our local SSID, which is our local bridge that we saw in the standalone mode. And there we have one called home, and then you could choose your WPA method and your key, so on and so forth. So basically kind of the same settings, but you're going to be going through and setting it up within Nebula slightly differently, but it's pretty much not as expensive as standalone. But you need to make sure that by all means you have to change your remote mode to remote AP for that device. And that's pretty much it on how to get things set up with the secure Wi-Fi. I'm going to go ahead and leave the floor open for some questions from Q&A.
Yeah, thank you, Marcus. The first question is, let's see here. Is there capability to use the second network port on the AP to connect another device through the tunnel?
So as of right now, if you're talking about some access points have two, they have two Ethernet ports. You can't use it as a pass-through for the tunnel.